Welcome back again to another learning video. Today, we're jumping into a topic that every developer dreams of, and honestly, kind of dreads at the same time: API scaling. We're going to go on a journey, starting with how you handle that very first user, all the way to supporting a massive global scale application. Let's get into it.
So here's the game plan. First, we'll get on the same page about what API scaling even is. Then we'll talk about the big choices you have to make with your servers. After that, we'll dive into the tools for managing a flood of traffic, tackle the infamous database bottleneck, and finally, we'll put all the pieces together into one complete, scalable blueprint.
All right, first up, what do we really mean by API scaling? I like to call it the problem of popularity. It is, without a doubt, a fantastic problem to have, but it's one that's going to need a serious engineering solution if you want to keep that popularity. So let's imagine this for a second. You built an amazing API, people absolutely love it, and your traffic is just going through the roof. Awesome, right? But then everything starts to get slow. The user experience takes a nosedive. What do? What's your next move? This right here, this is the moment a real scaling strategy becomes absolutely critical.
But here's the thing, scaling isn't just about making things faster. It's a really delicate balancing act. The real goal here is to handle a ton of requests and keep your response times low, sure, but you also have to keep the lights on, maintain high availability, all while not letting your infrastructure costs spiral out of control.
Okay, so let's move on to section 2 and see how we actually start building this out. We're talking about scaling the API servers. And this, my friends, is probably the first huge decision you're going to have to make. You're basically at a fork in the road. On one side, you have vertical scaling, or scaling up. That just means you buy a bigger, beefier server with more CPU and RAM. It's simple, but you're going to hit a wall eventually. There's only so big a server can get, and it's a single point of failure. On the other side, there's horizontal scaling, scaling out. This is where you just add more servers. And this is how modern, resilient apps are built for massive scale. So if you're going to scale out horizontally, there is one mandatory, non-negotiable rule you have to follow. Your API must be stateless. What that means is that no single server holds on to any specific user's session data. Any request from any user can be handled by any server in your entire fleet. This is the magic key that unlocks all the flexibility and resilience of horizontal scaling. Okay, so we've got a bunch of servers now. Great. But now what? How do we use them effectively? This brings us to section 3, managing the traffic flood. It's time to start building out our toolkit to actually direct and control all those requests coming in.
And the very first tool in that toolkit is the load balancer. Just think of it like a traffic director for your whole application. It sits out front and smartly spreads all the incoming requests across your servers, making sure no single one gets totally slammed. It's also smart enough to know if a server goes down, so it'll just stop sending traffic that way. It's absolutely essential.
Next up, and this is probably one of the most powerful things you can do, is caching. The idea is so simple but so effective. If you have data that gets requested over and over and over again, why would you hammer your database for it every single time? Instead, just store a copy of it in a super fast in-memory cache, like Redis. This slashes your response times and takes a massive load off your database. The hardest part, of course, is figuring out when to get rid of old data, a classic problem we call cache invalidation. And this is a great way to see that caching isn't just one thing you do in one place. You can and should do it at multiple layers in your system. You can cache stuff right on the user's browser. You can use a CDN like CloudFront to cache at the edge, closer to your users. You can cache at your API gateway. And of course, you have your server-side cache with Redis. A multi-layered caching strategy is really a sign of a mature, highly scalable system. The last tool for managing traffic is rate limiting. Think of this as the protective shield for your entire API. It stops any one user or client from completely overwhelming your service, whether they're doing it on purpose or they just have a buggy script running wild. It's absolutely crucial for stability and for protecting your system from abuse. All right, so our API layer is looking pretty solid now. It's horizontally scalable, it's load balanced, but now we have to face what I like to call the final boss of scaling. Let's get into section 4, solving the database bottleneck. So you've done everything right up to this point. You're scaling out, you're balancing traffic, you're caching like crazy, but under heavy load, things are still grinding to a halt. So what gives? Where's the problem? Well, 9 times out of 10, the bottleneck is database. It makes perfect sense, right? All of your beautifully scaled out API servers are all funneling down and hitting one single overwhelmed database. You can't just throw more app servers at this problem. The database itself needs its own separate scaling strategy. When it comes to database scaling, you've really got three main strategies. There's replication, where you just make copies of your database. That's great for handling more reads and for high availability. Then there's partitioning, which is about splitting one giant table into smaller, more manageable pieces. And finally, there's sharding. This is the big one. It lets you spread your data across multiple databases, which is how you scale your writes horizontally. But it's also the most complex, because everything depends on choosing a good shard key to distribute that data evenly. So how do you actually approach this in the real world? Well, a really smart way to do it is in phases. Don't just jump straight to the most complex solution. First, maybe you use partitioning to deal with some massive tables that are slowing things down. Then you add replication to scale out your read traffic and get that high availability. And finally, only when you absolutely hit the right limits of a single machine, that's when you introduce sharding. Okay, we've covered all the individual components. We've talked about servers, load balancers, caches, and databases. Now, in our final section, let's put it all together and look at the complete scalable blueprint. So let's follow a single request from start to finish. A client's request first hits our CDN or an API gateway. That layer handles the first line of defense, caching and rate limiting. The request then gets passed to a load balancer, which picks a healthy API server from a whole group of them. That server immediately checks our Redis cache to see if it already has the data. If it doesn't, a cache miss, then and only then does it go and query our database, which itself is scaled out using sharding and replication. This is what a real production-grade scalable system looks like. Now, if you are prepping for a system design interview, this slide right here is pure gold. You absolutely have to remember these principles. 1. Design your API to be stateless. 2. Always prefer horizontal scaling. 3. Cache aggressively. Cache anything and everything you can. 4. Monitor everything, your latency, your errors, your throughput. And 5, and this is a big one, choose your database shard key very carefully. And if you ever need to boil this all down into one powerful sentence, here it is. A scalable API is stateless, horizontally scalable, protected by rate limits, backed by caching, and monitored continuously. That one line perfectly sums up this entire explainer. So, as we wrap things up here, I want to leave you with a question to think about. Whether it's a small side project you're working on or a massive application at work, how are you going to apply these scaling patterns to make your next project more robust, more resilient, and truly ready for success? And that is our blueprint for API scaling. I would seriously love to hear from you. What are the biggest, gnarliest scaling challenges you've ever had to face? Let us all know your war stories down in the comments. And hey, if you found this useful, do me a favor and hit that subscribe button for more deep dives just like this.